The goal of Data Transformers podcast is to accelerate digital transformation by bridging the gap between business outcomes and rapidly advancing technologies. And we aim to bridge this gap by focusing on data. I am Peggy Tsai, top 50 women in tech influencer, co-author of the AI book, and data governance expert.
I'm Ramesh Danta, an entrepreneur, a tech blogger, and AI enthusiast. Hello all. Welcome to part 2 of our discussion with Shailendra Malik, Vice President, Technology Delivery at DBS Bank. So I think this is the evolution of Shailendra Malik is happening, across domains, from telecom to banking, and then from Saudi Arabia, India to Saudi Arabia to Singapore, and God knows what else. So the question is, going back, not going back, actually, it's a different topic that Peggy told me that you guys are working on. It's called the AI book. Okay. Yeah, so Peggy, sorry for stealing the thunder on that one.
I know, I was going to wait for the right time.
No, but I'm going to ask you the same question. You're also a contributor to that one. So I will be the interviewer for both of you on the AI book.
No, actually, before you begin, I'm actually holding the book in my hand. It's the AI book that's published by Wiley. It came out, I believe May or June of this year. I think because of COVID, again, there were some delays. And I actually was planning to go to the book launching party. It was rescheduled. Last I heard it was November, but I really don't think people will be traveling to London. But that was something I was looking forward to. But go ahead, Ramesh.
Yeah, so go ahead. So Peggy, you also wait for my questions on this one too, okay? So you'll not be asking any question in the AI book because you're a contributor to that one. So let's start with Shailendra. So what is this AI book about?
So the whole idea of AI book came along a couple of years back, and there is a FinTech group which is into publication and providing education as well and consultancy. It's called FinTech Circle. The group is based in London. It's run by Suzanne, and Suzanne is a good friend of mine. She came out with the overall call for abstracts for this book. And the intention was that a lot of, and an AI book is the fourth book of the series. So they started out with the FinTech book as their first book. Then came the PayTech book, which was more about the payments industry and how the use cases around payments industry is picking up. Third one was the InsurTech, where they covered the insurance part. And the fourth one was the AI. The fifth one is actually in the works, and it will be, I think it will be released by end of this year or early next year, is the legal tech book, which covers the legal technology part of it. So to be honest, I missed the first three opportunities to contribute in FinTech book and the PayTech book and the others. But I knew that when she discussed it and mentioned that AI book is in the works, I knew that I'd have to get involved in that project because it was too good an opportunity to lose. One. Second, it was an amazing experience to work with a lot of experts in the space. I during the abstract parts itself, when we were submitting the abstracts and then those abstracts went into a full voting cycle to get shortlisted and all, I get to meet at least 25 to 30 specialists in their own domains who were using AI as one of the solutions, and they have submitted the abstracts that I got a chance to talk to them. In fact, my interaction with Peggy also happened with the same background itself. So the AI book as a project itself has been a great collaborator, and then it brought a lot of people together to share ideas and then look into different cross use cases which we may not have looked into when we were focusing only around day jobs. So yes, that's where the AI book came along, and I was lucky and happy that my abstracts were selected and it were ultimately there in the book now.
So Peggy, over to you. Let me ask you a question. So what is your involvement in the AI book, and what's your story of how you got involved?
Yeah, so actually, Shailendra, I actually didn't know that you knew Suzanne and you knew her from the beginning. I actually happened to come across a LinkedIn post by one of my mentors, Nigel Walsh. He was a big contributor to in FinTech, InsurTech in the UK. And he actually posted something about a request for abstracts on LinkedIn. And I said, hey, this is a interesting idea. The concept is it's a crowdsourced book, right? So the bringing together all these experts, all parts of AI, because we all know it's a complex topic and how everyone is involved. And, Shailendra, I have to reiterate what you said. Not everyone gets chosen to be a part of the book. First, we had to write, I forget, a 500-word abstract. It's voted on. Could be a popularity vote or whatever, but it's voted on. And then if you get enough votes, then you get selected to write the 1,500-word essay article that gets into the chapter. So it's, for me, I think the whole process took a year almost, just from beginning to the end of writing it. For me, it was very exciting. I focused again on the data and data management aspect of AI and how it affects the modeling. But your chapter is called The Changing Face of Regulatory Compliance and Audit. And really, after hearing your experience, what you've done at DBS Bank, I understand why you've written this topic, but could you maybe elaborate a little bit more on your article and what other factors influenced your writing?
Okay, so the whole idea is that I wanted to contribute in this book with what I'm actually doing and the problem that we are trying to solve. I didn't want it to touch a kind of a aspirational problem that we may get at some point of time and then give a solution to that. So the bigger and biggest problem that we are facing in regulatory space as well as in the auditory space is how to cover the entire gamut of the transactions. And I'm talking about only the financial sector as of now, that while doing the audit, it's very easy to hide, or it's very easy to put a needle in a haystack if some fraudster is trying to trick the system. Mm-hmm. And there are so many products available in the market, financial products. There are so many transactions happening today that the whole field and the domain of compliance and audit is becoming very, very complex. The topologies from where we started maybe, say, 100 years ago in the auditory space, those topologies in itself have exponentially grown to thousands. That means there are known thousands of classifications of frauds that can happen in a financial system. Mm-hmm. The latest leaks that came along, the FinCEN leaks, shows or kind of highlights that how financial systems have been seen. FinCEN leaks mainly highlight about the SARs, which are very specific reports. Suspicious activity reports are known as SARs.
So, I'm sorry, Shailendra, I'm not familiar with that one. Can you elaborate a little bit more?
Okay. So you may have heard in the news cycles that a FinCEN leak has come in, and transactions from all over the world and different banks have been highlighted over there. And now the international body of journalists is claiming that all these are frauds that have happened, and money has been moved from one country to another, and then people are embezzling money here and there. So there has been a very, very strong focus coming in from anti-money laundering and task force like FATF. They are trying to curb down on the money movements which are going towards terrorist activities or unlawful activities. So that also comes into the gamut of compliance and regulatory space. And with this leak, it also highlights that how big the overall financial industry is.
I see.
And the regulators sometimes become far more bottled with the amount of transactions that they get to validate and to go through to check whether any fraud is happening there or not. So if you get billions of transactions every month to be seen in a report, how practical it is for you to go through all those transactions and identify the patterns of frauds that can come out of it. So that's where I was highlighting that this is a space where AI and machine learning can do wonders, because we end up doing sampling. That instead of going through the entire universe of transactions, we pick select samples by doing sharper sampling, by identifying that, okay, these transactions are looking to be more probabilistically high to have some sort of fraud going on. And we pick that as a sample and run through with our check systems that, yes, whether this transaction is really a fraud transaction or it was just a regular transaction. So that particular space, with all these tighter regulations coming along around AML, around other spaces, we need to move towards covering the entire universe rather than doing the sampling. Which means that can only be done when the automation or an AI or a machine learning model is working in the background, which can do that kind of validation far faster than a human analytics team can do for you. Only then you can do a full coverage. So that is one. Second part where AI can help is that once we start covering the full universe, today many banks or many financial institutions, they cover the data on a daily end of the day jobs. That there is a end of the day job which will cover the entire transaction, then it will go through all those transactions to see the anomalies or some sort of suspicious behavior and then flag those transactions off. And that's where you see that, okay, a few thousand transactions were kind of filtered out from the millions of transactions, and now we'll have to focus on only these transactions next day. But can we move into the space of real-time fraud detection, where we can catch the fraud as and when it is happening?
Yeah.
At least for the known ways of fraud. People are tricksters. They are trying to game the system with new ways as they can. And then those ways can only be discovered later and then get fed back to the system to catch those kind of things as well. But at least the known frauds or the known ways of cheating or known ways of gaming the system, can we implement those ways in such a way that they can catch the perpetrator right at the time of the act, rather than catching it next day? Because sometimes the transaction has already happened, money is already gone, and you cannot do about it. You just know that this XYZ account did something and the money is gone. And you try to catch that person by raising alerts that, okay, if this account is seen somewhere else, please be reminded that this account is supposedly a fraudster or a scammer. And then you hope to catch that account or catch that person in their act later because they have been now red flagged in the system. But can we move from this process to a far more aggressive process of catching them in their act? And if that needs to happen, that means your daily jobs have to move into a real-time event-driven process, which catches it on the seconds by seconds basis. And you move away from data transfer as a batch to a data transfer as a stream.
Correct.
And then that's the major big data leverage that can happen today, which was not possible 10 years back. So, and if we couple that with the right AI models or right machine learning models, we can go even a further step ahead by preventing that happening as soon as that transaction is even highlighted for execution. So from detection, delayed detection to immediate detection to prevention. That's where AI can actually help the regulators to cover the entire universe and make the system a bit more airtight.
Correct. I mean, you're going through the evolution of the whole analytics spectrum there. So one of the things that struck me in this whole discussion, we started off the discussion with the models, the maintenance and all the stuff, and then how do you apply them to audit and then the fintech in general. But one of the thread that's been going throughout the discussion today is the data, right? The amount of data, the billions of the points of data, and there is this assertion that the models and model maintenance is 10, 20, 30% maximum of the data scientist work or data science work. And the majority of it is like the data wrangling, data munging, all that stuff. So from your experience, Chandra, can you talk about how much time are you spending in classifying data, cleaning the data, in all the data management aspects?
Okay, so I have a slightly different take for this, and then I know some people may get upset with this, but I come from an engineering background, and according to me, there are different classifications of these problems. So one is a data problem and data engineering problem. How you engineer that data, which includes your quality checks, which includes your assertion that bad data doesn't enter the system, and then all the entry points of the data are also cleaned up. Second part is your systems engineering, where the big data problem comes in. How do you scale up according to your data? If data is coming high, transaction volume is very high, how would you scale up your compute power so that you can manage that particular data and then look into that data and do not compromise on your overall application performance or system or product performance.
Mm-hmm.
So that is a kind of an infra engineering problem. One thing which I feel that people don't focus much is when they talk about ML, they generally pick a few kind of ML models. They run them through, and then they feel that, okay, now we have selected a particular model and we are done. And they forget that deploying of that model or usage of that model as a component in the overall picture needs to be part of a systems engineering as well. So data scientists, they usually focus on building that model or picking the right model from all the plethora of models that they have, playing around different weightages, looking on different parameters on that to fine tune that model to get the perfect precision, to get the perfect accuracy of that particular model that fits the use case. And once they do that, they just say that my model is done. Application good. That is not true, because that model needs to have an instrumentation layer around it, where that model will go and get plugged in. You are practically saying that okay, I'm a bit of a Marvel universe fan. So you have created. So for you talk about Iron Man, you have created that particle collider, but you haven't created the Iron Man suit. So how will you fly? that collider will not take you anywhere. It's the jetpack in the suit that will take you somewhere else. So model is that, but you need to build the suit to carry it as well and use it properly as well.
Yeah.
Now, another problem that comes with it is once you build the suit, people don't build or plug those models as a pluggable component. They build an application around that model, and the application end up becoming very, very tightly coupled application.
And very rigid.
If 1 year later, use case changes slightly, and you feel that your current model is not apt or it has to be dropped and some other model needs to be used, you will have to go through the entire process of instrumentation again. That has happened with me in one of my old projects. That we build the application around a particular model, and then we have to. We discovered later that there is a huge technical debt coming with it, because tomorrow, if the model needs to change, there are a lot of touch points on the instrumentation that will change with it as well. So that pluggability of the model, there are frameworks already available in the market. There is a group called Data Mining Group, DMG. You can look for their website, dmg.org. They are very much like a group like DARPA was at one point of time when they were working on internet as a project. They came up with models like PMML, which is predictive modeling language, or it's kind of a framework where you can create a model and then you can plug in and plug it out just like any other component. They have containerized the entire process of a particular model, and you can use it. Just that the compatibility of that particular framework was limited only to certain languages, not to all.
I see.
So a few years back, they came up with a revised model called PFA, which ensures that even if you're using R, Python, any sort of language to build a model, you can still use PFA as a ground framework to build an application around it where a model can be plugged in, plugged out at your wish.
I see. Cool.
There are other projects like Apache has come up with Databricks. So if you're using Databricks, you can easily plug models at your will, and you can choose which model will step in at what particular point of time. In fact, you can also select that if the nature of the data is changing because of the difference in volume of transactions or nature of transactions, a different model can kick in at that particular point of time. Even that kind of instrumentation can be done as well.
Very dynamic.
Very dynamic. So that space is evolving, but not everybody or not all companies are focusing on that side of instrumentation. They're only focusing on building the model and then just get done with it. So that was one problem. Your original question was about data and how much time I spend to wrangle the data and work with the data, or at least how much time the data scientists spend on it. I feel that problem is mainly with the legacy data, not with the new applications.
I see. Okay.
Because when we build the legacy applications, we practically didn't know what all new data sets that may be required in the future. So when a new use case comes in, and that use case requires a particular type of data set which was not being captured, or a data point which was not being captured historically, that's where the problem comes. Because for certain data points, you have entire historical data. But for certain data points, you have data only for past 1 year, because your new system started capturing the data only from past 1 year itself.
Yeah.
So you aggregate the data for the historical time, and then from past 1 year itself, you come up with the full universe of data. And that means when you train your model, the credible data it can work on is actually only 1 year old. And in some cases, only 6 months old. Because that application was put into place only recently, because those kind of data points were discovered fresh. That, we need these kind of data points for us to be able to have a better insights coming to us. So that is one. Second, another problem that comes with legacy, and then it happens in many banks that I've worked in before, is that people put in bad programming practices. It is unfortunate, but it does happen.
Yeah.
As simple as using a pipe delimiter. So these kind of basic problems still exist in the market. And then legacy applications are the biggest culprits on it, because you do not even have people who know about those applications, that how to modify them. And the only option left is that you build a new application and then hope to migrate from this old application to that new application so that the whole problem will go away.
Keyword you use a hope. The hope is, you just hope.
And that hope gets transferred year on year. So that's how sometimes some of the legacy applications become the kind of party pooper for the entire story to be told slightly differently. So things could have been much more greater, but just because of 2 or 3 laggard applications, the whole picture looks a very different thing.
Shailendra, that's really interesting, and obviously a lot of banks, not just DBS, is facing these issues. In the ideal world, ultimately, in the ideal corporation, who should ultimately be responsible for making sure all these problems are smoothed out? Not just who in the organization, but should there be another governing body that does the checks and make sure that these type of technology patches are smoothed out? And what are your thoughts?
So, okay, there are governing bodies for the system engineering side, as I mentioned, because the big data revolution is nothing new. It is happening in the industry for the past 10 years now. And people are stepping into, especially the early adopters, they started experimenting with the cloud infrastructure and big data infrastructure kind of early in 2010s itself. So that part and that governance is already happening. I think the focus on data is relatively a new story. And DBS has been very pragmatic about this, because when this AIML journey started in DBS way back in 2016, at that time itself, they realized very quickly that whatever is going in, it's as simple as garbage in, garbage out. So if you don't focus on data, your machine learning models may not be able to give you the leverage that you want to have. So DBS established a data platform way back in end of 2017 itself. And then the conceptualization of data platform, which covers the entire data governance, was put into place there. But they are there to provide guidelines and an overarching strategy of managing the data. They will give a basic framework that this is how all applications in the bank should be treating their data. But then it comes a responsibility for each and every department, each and every tech team to make sure they comply to those guidelines. Because if the compliance is not happening, then you're not going to get there. And that's where DBS changed its own entire operational approach from the traditional IT department to a platform-centric approach back in 2018 itself. That the whole bank was divided into 33 platforms. Audit platform came along at the same time as a separate platform. But there are platforms around compliance. There are platforms around consumer banking. There are platforms around institutional banking. Different departments of the bank, they came up with a platform approach in such a way that the tech team sits closer to the users, to the business users. And whenever a new use case is being talked about, tech is there, right there at that particular table, understanding the problem and even giving them ideas how to tackle it. So yes, there are different approaches followed by different companies. I think DBS has pretty much figured out that way of how it will shape up. And we are pretty much well ahead in that journey. And this has been recognized by the industry as well with the transformation projects that DBS is running for the past couple of years.
Wow, what a great discussion, Shailendra. I think we covered, a lot of spectrum here, your own journey, and then from within the FinTech itself, the model management and data evolution. So any final thoughts and then next steps for you personally, and then what else is going on in the industry that you see in the next 1 or 2 years?
Okay, so I think I do want to cover the COVID part and what COVID has done to the industry in general.
Yeah, please.
Because no conversation today is complete with covering that particular part.
Yeah.
And this question has come to me a couple of times in my discussions with my fellow AI book contributors, as well as those who have read the book, and they have come back to me asking for more questions. So to be honest, when I wrote the book, or when I wrote that chapter, which got selected, my whole focus was that how the evolution of industry will happen in the next 5 to 10 years, and how the trends will evolve going forward. And what COVID has done is kind of squeeze that 5 years into 2 years.
Yep.
The things are the trends that we were focusing that, okay, this would happen in next half a decade. We have seen those projects being taken up in 2020 itself. Just because the volume of transactions suddenly jumped up. Everybody is now doing online transactions. Everybody is now working from home. So data security side, the fraud probability side, the phishing attacks, and all those things which we wanted to cover or kind of increase our coverage as a full universe in next 3 to 5 years as an industry, that had to crash down to a single year or maybe at max 2 years. So AIML has kind of helped us in many ways, which I feel that these tools were available to us at the right time, that many banks and many companies could leverage them, even though in the rudimentary way, to solve a lot of these problems that COVID threw at us. So that is something that I wanted to cover. One. Second, in the evolution side for the industry, in the overall piece, I guess AI, I still feel that the maturity of the sector or this particular technology in itself is due. What we are doing is just taking baby steps in improvising our use cases and improvising on our model usage and model implementation. There is a radical jump that is due for the industry. There is a debate happening already in many circles that deep learning or the current ML models, they are very, very heavily dependent on the data. And these models struggle where the data is sparse. So how to manage those kind of use cases? And there is a very healthy and sometimes heated debate going on in many sectors and academia as well, because the research fraternity, they talk about it a lot. And especially when you use machine learning or AI models in far more critical use cases like autonomous vehicles and IoT and those where failure may cause a death as well. So their dependency on data is seen as one of the bottlenecks, that if you don't have data, you may not be able to get the best results from those models. So yes, I think industry in next 5 years will go through a quantum leap. I'm not talking about the quantum computing. We'll go through a leap of maybe adopting a very, very new way of ML or AI, that jump may happen. And that may be facilitated with quantum computing as well.
Yeah, I was about to say that exactly.
Yeah. So that is a different stream or a different parallel universe that is building up. If that happens, whatever controls we have put in place, even your encryption levels of 256 RSA or whatever you call it, or 512 RSA, all those encryptions will go for a toss if the quantum computing figures out the way to manage things the way they are promising to, because then encryption will really go out of the window. And this will change the financial sector, especially because our financial sector is one of the most dependent sector on the encryptions to keep the money safe. So if quantum computing comes along, you'll see a very radical change in the industry.
Thank you, Shailendra, so much for your time, your insights today. I think we all learned so much from you, and appreciate your time today at the Data Transformers podcast.
Thank you so much.
It was a very practitioner view of the world. It is not a pie in the sky, so I really like this discussion.
And that's what we need more of, so thank you.
Thank you for listening to today's episode. If you liked what you heard today and would like to hear more, please subscribe to our podcast on your favorite player like iTunes and Spotify. And please do rate our podcast. Also, please go to our website, www.datatransformerspodcast.com, for more episodes, blogs, and information on our speakers. Thank you.